Hi everyone, welcome to geometry class. Today we're going to be discussing distance in the coordinate plane. We're going to finish up chapter 1, section 6, so grab your textbook and turn to page 44, and we're going to start there. By the end of this video, you'll be able to answer these questions. How do you apply the Pythagorean theorem to find distance on the coordinate plane? And what is the distance formula? And finally, how do you use the distance formula to find distance on the coordinate plane? Let me first start by asking the following question. Where is finding distance used in real life? So if I wanted to find how far New York City was away from Paris, France, I would need to know what the distance is between those two cities. So we are going to answer this question today. How do we find the distance between these two locations? So today I'm going to be using the words distance and length interchangeably. That means that they mean the exact same thing. It's a measurement of how far apart 2 points are. Okay, so today we're going to be working on the coordinate plane. Remember, a coordinate plane is a plane where I have an x-axis and a y-axis. And I can plot points based on their x-coordinates along the x-axis and their y-coordinates along the y-axis. So I've plotted 2 points here. I've plotted point E and I've plotted point F, and I've created a line segment EF. And today I want to answer the question, how long is line segment EF? What is the length of line segment EF? And I've posed this question right here. Okay, very good. So we are going to be using 2 methods to figure out what the length of line segment EF is. The first method we're going to use is the Pythagorean theorem method. Okay, now recall that the Pythagorean theorem is a way to relate all 3 sides of a right triangle to each other. Okay, remember, a right triangle is a triangle that has one right angle, only one right angle. And a right angle is represented by this symbol, this box symbol, means perpendicular, in this triangle right here. Okay, so let's see how we can use the Pythagorean theorem to find the length of line segment EF. To use this method, the first step I want to do is draw a right triangle on the coordinate plane. And how I'm going to do that is I'm going to start at point E and draw a vertical line segment down to the same level as point F. So I'm drawing this side of the right triangle right here. So you go ahead and do that as well. I'm also going to draw a horizontal line from point F to complete the right triangle right here. Very good. Okay, the last part of this step is to label the sides of the right triangle. Okay, so let's go back to the legs of our right triangle. The legs of the right triangle are the shortest sides of the right triangle. So I have the vertical leg right here. I'm going to label that leg A, or side A. I also have leg B right here. I could interchange those 2 sides, so I could label this side B and this side A, but for right now, for this example, I'm going to call this side A and this side B. Now, the side that makes a difference as to what it's called is the side that's known as the hypotenuse. The hypotenuse is the longest side of the right triangle, and it's always across from the right triangle. And we always label the hypotenuse side C. Okay, great. So, the next step in the Pythagorean theorem method is to find the lengths of each of the legs of our right triangle. Okay, so remember, we have side A and we have side B. And how I'm going to find the length of each of the legs is I'm just going to count the number of squares along each of the sides. So I have, along side A, I have 1 square, 2 squares, 3 squares, 4, 5, 6. Fantastic. And I'm just marking them as I go. So the length of side A is 6 units. Great. Let's do the same thing for side B. 1, 2, 3, 4. So I have 4 units, 4 squares for the length of side B. So side B is 4. Now, using the Pythagorean theorem, if I know two sides of a right triangle, I can always find the third side. So you can see I know two sides, but I need to find side C, which happens to be the length of our line segment EF. So step 3 is to use the Pythagorean theorem to find the length of our line segment EF. I've rewritten here our Pythagorean theorem. So go ahead and stop right now and write in your notes the Pythagorean theorem. This might be a review for some of y'all, but I want to make sure that you all are on the same page with what the formula is. A squared plus B squared equals C squared. So at this point, I know what the value of A is, and I know what the value of B is. I need to find C. So using the Pythagorean theorem, I can plug in the values I know for A and for B. I know the value of A is 6, and I know the value of B is 4. Now, notice here that I'm keeping both terms raised to the power of 2. So 6 is raised to the power of 2, and I'm adding that to the term 4, which is also raised to the power of 2, equals C squared. This is following the same format as the Pythagorean theorem. I've only now plugged in my values for A and B. That's line 2. Let's move on to step 3. Now let's look at what power does in this term. When I raise something to the power of 2, what I'm really doing is multiplying the base, in this case 6, by itself twice. So 6 squared is really just 6 times 6. Okay, great. Now likewise, 4 squared is just 4 times 4. So now all we have is a multiplication and addition problem. Fantastic. It still equals C squared. Okay, so our next line, what I can do is take 6 times 6. We know 6 times 6 is 36, and 4 times 4 is 16. So I have just these two like terms here now, and it still equals C squared. Since 36 plus 16 are like terms, I can add them together. And when I add them together, I get 52. So 52 equals C squared. Now remember, I want to know what the value of C is, not C squared. So to take off the power of 2, to undo that operation, I need to take the reverse operation. The reverse operation of the square is the square root. So I'm going to take the square root of both sides, the square root of 52 and the square root of C squared. Okay, so when I take the square root of 52, I get 7.21, which is an approximation. It's rounded to the nearest hundredth, or 2 decimal places. And again, when I take the square root of C squared, I just get C. So I have found what C is. So C, or the length of EF, is 7.21. Great job, guys. You've used the Pythagorean theorem to find the length of a line segment on the coordinate plane. Okay, so the next method, the second method we are going to use to find distance on the coordinate plane is called the distance formula. So we have our coordinate plane right here, and we have the same line segment EF on the coordinate plane. Okay, and the same question stands. I want to figure out what the length of line segment EF is. The first thing I want us to do is find and label the coordinates of each of our points, E and F. Alright, what we need to do is find the x and y coordinates of each point. So let's start with point F. The x coordinate we're going to find by traveling along the x-axis. So I'm going to start at the origin here, and I'm going to move in the positive direction towards the points. So I have 1, 2, 3, 4, 5, 6 is our x-coordinate. Great. And I'm going to move towards the point along the y-axis vertically. 1, 2. Good. So our x-coordinate of point F is 6, and our y-coordinate is 2. Okay, now we found the coordinates. Step 1 also says we need to label the coordinates. And what I mean by that, right here I've labeled the x-coordinate x1 and the y-coordinate y1. And that little number 1 means it's my first point. It's just going to distinguish it from the next point we find, point E. Great. Alright, so let's find and label the coordinates of point E. Starting at the origin again, I'm going to move along the x-axis towards my point. So I have 1, 2 is our x-coordinate. And let's move along the y-axis towards the point along the y-axis. 1, 2, 3, 4, 5, 6, 7, 8. Great. So our x-coordinate is 2 and our y-coordinate is 8, like we just found. So we found the coordinates. To label the coordinates, I have x2 for my x-coordinate and y2 as my y-coordinate. The 2 represents that it's my second point that I found. Okay, great. Step 2, what we're going to do is draw a right triangle, just like we did in method 1 using the Pythagorean theorem. So go ahead and draw a vertical line and a horizontal line to complete your right triangle. Fantastic. Step 3, what I want us to do is determine the change along each axis that point F has to move to get to point E. Let me show you what I mean. We'll start with the y-axis. If I start, let's start at point E actually. If I start at point E, I have to move along the y-axis down to the same coordinate, same y-coordinate as point F. And point E has y-coordinate 8. Point F has y-coordinate 2. So, if I were to move along the y-axis, I would have a length of 6 units to travel to get to point F from point E. So this actually represents the same length of side A from our Pythagorean theorem. So you can see how the distance formula is actually following the Pythagorean theorem. Okay, great. I've expressed this mathematically here. The change in y values, y2 minus y1, equals 8 minus 2, it's just the coordinates, equals 6. That's the length along the y-axis. Great. Let's do the same thing along the x-axis. I'm going to start at point E, which I have labeled x2. The x-coordinate is as x2. And I'm going to travel along the x-axis to get to point F. Just staying along the x-axis. So x2 is 2. That's the value of that coordinate. And x1 is 6. So I've traveled a length of 4. But mathematically, the difference of x2 minus x1 is 2 minus 6, or negative 4. And that's okay that it's a negative number. We're going to see how that works out in just a second. But again, before I move on, this difference, this distance that I've traveled along the x-axis, is the same leg as side B in the Pythagorean theorem method that we just completed. Okay, great. So keep that in mind. So I've captured both the change along the y-axis and the x-axis and plugged in the values for each of the coordinates. We're going to use that in just a moment. Before we actually apply the distance formula, let me tell you where it comes from. So we just finished looking at an example using the Pythagorean theorem. The distance formula is the Pythagorean theorem, only I've replaced A, B, and C with coordinates. So A, I've replaced with the change along the y-axis, or y2 minus y1, and B, I've replaced with the change along the x-axis, or x2 minus x1. And then C, I've replaced with D, or distance, the distance between the 2 points E and F in this case. Okay, so what I'm doing now is just manipulating the equation to get to D. Like we did in the Pythagorean theorem, I just wanted to find C, and in the distance formula, I just want to find D. So in this second step, I'm taking the square root of both sides so that I can reverse the operation of the square, and I'm taking the square root of both sides. And in the third step, once I've taken the square root of both sides, I just have C. And likewise, I have the distance formula after I've taken the square root. I just have D, which is the distance. Okay, so please stop, write in your notes the distance formula. So it is the square root, and everything underneath is underneath the square root. The difference along the y-axis, y2 minus y1 raised to the power of 2, plus the difference along the x-axis, x2 minus x1 raised to the power of 2. Fantastic. Now let's actually apply the distance formula. Plug the values in we found and find the distance between these 2 points, E and F. Okay, so that's the last step, applying the distance formula. I've written the distance formula down here. I always want you to start with that after you've labeled your points. So now I'm just plugging in the values. y2 minus y1 is just 8 minus 2. Put that inside the parentheses. And then x2 minus x1 is 2 minus 6. Again, inside the parentheses. Okay, so everything inside the parentheses is squared for both of these terms, and then the whole right-hand side is underneath the square root symbol, or the radical. Okay, so let's move down to line 3. I'm just taking the difference between 8 and 2, 6. And again, the difference between 2 minus 6 is negative 4. All right, now let's see that both terms are raised to the power of 2. And like we saw in the Pythagorean theorem method, raising something to the power of 2 means I take the base, or the big number, and multiply it by itself 2 times. So 6 squared is just 6 times 6. And negative 4 squared is just negative 4 times negative 4. Great, and that's what this step shows. So our next step, I'm just simplifying the multiplication problem of squaring. So 6 times 6 is 36, and negative 4 times negative 4 is going to be positive 16. Remember, a negative number times a negative number is a positive number. So when you've gotten to this step, every time in the distance formula, you should always have 2 positive numbers. You should never have any negative numbers at this step. Great. Now since 36 and 16 are like terms, I can add them together, and I get 52. But remember here that everything is still underneath the radical, or the square root symbol. So I have the square root of 52. When I put that in my calculator and simplify that, I get the approximate length of 7.21 as the distance, or the length of line segment EF, which is what we found using the Pythagorean theorem method. So, using either method, we get the same length. Great job, guys. I know that seemed like a lot of work, but the beauty of the distance formula is once you've gained confidence using the formula, you can go directly from labeling your coordinates here to plugging it in to the distance formula here. So that actually would cut out steps 2 and 3, and you can go directly to only applying these steps. So that is why the distance formula is used for the coordinate plane. Okay, finally, let's answer the question we had at the very beginning of this video. How is the distance formula used in real life? So, Google Maps uses the distance formula to find the distance between 2 locations. Google Maps uses what's called coordinates, called latitude and longitude, to find the distance using the distance formula. And in our example, we wanted to find the distance between New York City and Paris, France. So Google Maps tells us using the distance formula that between those 2 cities, there is a distance of 3,627 miles. Great. Okay, guys, so in review, we can find the distance or length on the coordinate plane using the Pythagorean theorem or distance formula. Great job, guys. I'll see you next time.